Hello students, we are happy to have you join us on this exciting journey into the world of computers with binary brains, the language of computers. Grade 8 Lesson 5. We are going to learn about data analysis, introduction to libraries, Pandas, NumPy, Matplotlib, Seaborn. Let's begin. In today's world, data is everywhere, whether it's information from social media, shopping websites, or even schools' attendance records. Using Python, users can analyze this data to gain useful insights and make better decisions. Data analysis. Data analysis is the process of organizing and examining data to find useful information. Imagine you have a lot of numbers or facts and you want to understand what they mean. Data analysis helps make sense of that information by looking for patterns, trends, or anything important that can help make decisions better. Data analysis is used to gain meaningful insights by looking at the data. It helps solve problems like figuring out why sales are low in a store and can be used to predict future outcomes, such as estimating how many people will attend an event based on past numbers. Data analysis is used in many different areas. Business and marketing. Companies use data analysis to improve efficiency, make smart decisions, and predict outcomes. It helps them spot market trends, high demand products, and customer needs to create better offerings and targeted marketing. Finance. Banks use data to improve service, manage risks, detect fraud, and develop products. Investors use it to predict markets, improve portfolios, and spot investment opportunities. Healthcare. Doctors and hospitals analyze data to improve patient care, spot health issues, and manage operations. They track trends and find effective treatments. Technology. Tech companies use data to upgrade products, detect fraud, protect data, target users, and boost efficiency. Government. Governments use data to plan better, make decisions, cut costs, and improve services. It also helps understand public needs and manages law and order. For example, you are the coach of the Indian cricket team and you want to make informed decisions and increase team efficiency for an upcoming tournament. You have lots of information about each player, their past performances, their past scores, the type of pitches, their performance against specific teams, etc. By data analysis, you can make informed decisions like pick the best player to play in the tournament, decide on the game strategies, plan the batting order and bowling order, plan the fielding setup. So data analysis helps the cricket team make smart choices and improve their chances of winning matches by using information to their advantage. Similarly, data analysis is incredibly useful in many other fields to help make better decisions and achieve goals. Introduction to libraries. Libraries are collections of ready-made code that other people have written. Instead of writing everything from scratch, you can use these libraries to do specific tasks quickly and easily. To develop large codes with basic Python requires a lot of time and effort. That's where data analysts and companies use external libraries, thus saving time and effort that would otherwise be required to develop larger codes. Let us know about some well-known Python libraries used in data analysis. Pandas, a powerful library for working with structured data like tables. It helps in data cleaning, manipulation, and analysis. NumPy, a library used for numerical computations. It provides support for working with large arrays and matrices of numerical data. Matplotlib, a popular library for creating basic graphs and charts. such as line plots, bar graphs, and histograms. A library built on top of Matplotlib. Seaborn makes it easier to create more advanced and visually appealing graphs. Pandas. Pandas is a powerful open source library in Python designed for data manipulation and analysis. It offers easy to use structures like series for single columns of data and data frame for full tables, and provides a wide range of functions to clean, manipulate, and analyze data. Pandas is especially useful when working with structured data such as tables with CSV files or databases. Please note that the Python IDE does not come pre-installed with Pandas. You need to explicitly install it in your system. Installing Pandas. Pandas comes pre-installed in Google Colab. For other IDEs like Python IDLE, install it using pip install pandas. This command uses pip package to install pandas from Python package index pypi. Verifying installation. To confirm installation, run the following code. Note: double underscores are used before and after the version. If Pandas is installed successfully, it will display the installed version number. For example, it shows 2.2.2. Pandas provides two essential data structures: series and data frame. A series is like a single column of data, similar to a list of Pythons where each value is labeled with an index. A data frame, on the other hand, is like a full table with both rows and columns, where each column is a series. It's essentially a collection of multiple series combined into a structured table, making it easier to analyze, filter, and manipulate data. Understanding Pandas data structures. Suppose we have data about students and their scores. Let's see how we can use Pandas to create a table and analyze it. Type the following code in Google Colab Notebook. We import the Pandas library using the keyword import, and the keyword as is used to assign a shorter name PD to the imported Pandas library, so that instead of writing Pandas every time, you can write PD. Here we have created a data frame to organize data about students' name along with their maths and science scores. Using Pandas, we calculated the average math score and sorted the table by science scores from highest to lowest. Now run the code to see the output. The output first shows the student data in the table with their math and science scores. Then it calculates the average math score as 86.6 using Pandas. Finally, it displays the table sorted in descending order of science scores with the highest scorer Nitin at the top and the lowest scorer Arya at the bottom. Thus, we can see that using Pandas simplifies tasks, allowing us to perform data analysis efficiently without needing complex code. Important functions used in Pandas. Size function returns the number of elements in the series or total elements in the data frame. For series, it returns the number of rows. For data frame, it returns rows into columns. Let's run the code to see the output. In the code, the series contains 4 elements: 10, 20, 30, 40. So its size is 4. The data frame has 2 rows and 3 columns, giving a total of 2 into 3, that is 6 elements. So its size is 6. Endim function represents the number of dimensions of the object. Let's run the code to see the output. A series is one-dimensional, like a single column of data. So output for series endim is 1. A data frame is two-dimensional, rows and columns, like a table. So output for data frame endim is 2. Copy function creates a copy of series or data frame. Let's run the code to see the output. A copy of original data frame df is created and stored in dscopy. Main function computes the average of numerical values in series or data frame. Let's run the code to see the output. The output shows that the calculated mean for each column for column A is 1.5, for column B is 3.5, for column C is 5.5. Since the output of the calculated means are in decimal values, the output shows D-type float 64. It tells you the type of the values. Median function returns the median value, that is middle value of each numerical column when arranged in ascending order. Let's run the code to see the output. Let us see for odd data frame 3 rows per column. Column A when arranged in ascending order is 10, 20, 30. The middle value is 20. Thus, the median of column A is 20. Similarly, for column B, the median is 15. Now let's see for even data frame 4 rows per column. Let us run the code to see the output. Column A when arranged in ascending order is 10, 20, 30, 40. The middle two values are 20 and 30. The average of 20 and 30 is 25. Similarly, for column B, the median is 20. Standard function returns the standard deviation of numerical columns. Let us run the code to see the output. Standard deviation tells us how spread out the numbers are based on the mean. Column A 1, 4. Numbers are not too far apart. Mean 2.5, spread around plus or minus 1.5, standard deviation 2.12 small spread. Column B 3, 8. Numbers are a bit far apart. Mean 5.5, spread around plus or minus 2.5, standard deviation 3.53 medium spread. Column C 5, 16. Numbers are very far apart. Mean 10.5, spread around plus or minus 5.5, standard deviation 7.77 large spread. Value counts function returns a series containing counts of unique values. It is used only on a single column, not whole data frame. Let us run the code to see the output. In the series, blue appears 3 times, red appears 2 times, green appears 1 time. Pandas shows these counts in descending order of frequency. Name count means output is a panda series named count, and D-type int64 means its values 3, 2, 1 are stored as integers. NumPy NumPy, which stands for Numerical Python, is a powerful library in the Python programming language used for numerical and mathematical operations. NumPy is a fundamental package for scientific computing in Python and is widely used in various fields such as data science, machine learning, physics, engineering, and more. Note: NumPy is not included by default in your Python IDE. Therefore, it is necessary to install NumPy explicitly on your system. Installing NumPy. The NumPy library comes pre-installed in Google Colab. For other IDEs like Python IDLE, install it using pip install NumPy. This command uses pip package to install NumPy from the Python package index, that is pypi. Verifying installation. To confirm installation, run the following command. Note: double underscores are used before and after the version. If NumPy is installed successfully, it will display the installed version number. For example, it shows 1.26.4. Understanding NumPy. Type the following code in the Google Colab. We import the NumPy library using keyword import and the keyword as is used to assign a shorter name NP to the imported NumPy library. So that instead of writing NumPy every time, you can write NP. This is a small data set to test scores to calculate the average score and determine highest and lowest scores. In this code, the npmean function calculates the average score from the dataset. The npmax function identifies the highest scores. The npminimum function determines the lowest scores. Now, let us run the code to see the output. The code first creates a list of test scores named scores and converts it into a NumPy array named scores array. So mathematical operations become easier and then calculates the average scores, highest scores and lowest score and then displays the result of the calculations along with score array. It converts into a NumPy array named scores array. So mathematical functions become easier and then calculates the average score, highest score and lowest score. The code first creates a list of test scores named scores and then converts it into a NumPy array named scores array. So mathematical operations become easier and then calculates the average score, highest score and the lowest score and then displays the result of the calculations along with the scores array. Important functions used in NumPy: add, subtract, multiply, divide functions. These functions perform element-wise operations between arrays. Let us run the code to see the output. For addition, each element of A is added to the corresponding element of B and the calculated sum is shown in the output. For subtraction, each element of B is subtracted from the corresponding element of A and the calculated difference is shown in the output. For multiplication, each element of A is multiplied to the corresponding element of B and the calculated product is shown in the output. For division, each element of A is divided by the corresponding element of B and the calculated result is shown in the output. The result is in the decimal form, that is 10.0, because division in NumPy returns float even if the answer looks like a whole number. Dot function, used to compute the dot product of two arrays commonly used in linear algebra. Let us run the code to see the output. The dot product multiplies corresponding elements of two arrays and then adds them up. So the output is 11. Square root function computes the square root of each element in the array. Let us run the code to see the output. The output shows the square roots of the given numbers. Main function calculates the average value of all elements in the array. Let us run the code to see the output. The output is 25, which is the calculated average of all the elements in the array. Median function finds the middle value when all elements are sorted. Let us run the code to see the output. The output is 25.0, which is calculated median value of all the elements in the array. Standard deviation function computes the standard deviation of array elements, tells how spread out the values are. Let us run the code to see the output. The output shows the value of standard deviation of all the elements, that is 10, 20, 30, 40 in the array. Variance function calculates the variance average of squared differences from the mean. The output is 125.0, which is calculated variance of all the elements in the array. Please note certain formulae may be outside the scope of your mathematics curriculum. Here, it is only important to know the functions provided by NumPy. Minimum and maximum function. Find the smallest and largest values in the array. Let us run the code to see the output. In the array, the smallest number is 10, so it prints minimum 10. And the largest number is 70, so it prints maximum 70. Matplotlib. Matplotlib is a popular Python tool that helps us create visual representations of data like graphs and charts. It gives us visual representation of the information, making it easier to understand. It also helps to see patterns or trends in the data. Let us learn about some key aspects in Matplotlib. Plotting graphs and charts. Matplotlib allows you to create different types of graphs like line graphs, bar charts, pie charts, and scatter plots. Customization. You can easily customize your plots by changing colors, labels, titles, and adding grids or legends. Easy to use. It provides simple functions to create and display graphs, making it beginner friendly. It integrates well with other Python libraries like NumPy and Pandas, which makes it useful for data analysis and scientific computing. Interactive and static visualizations. You can create both static images and interactive visualizations that respond to user input. Basic types of plots in Matplotlib. Matplotlib offers various types of basic plots, and three common ones are line plot, bar plot, and scatter plot. Here's a brief introduction to each. A line plot is a type of graph that displays data points connected by straight lines. It's commonly used to show trends or patterns, making it easier to see how data changes over time. Line plots are helpful when you want to track progress or compare changes in values across different time periods. A bar plot. A bar plot is a type of graph that displays data using rectangular bars where the length of each bar represents the value or quantity of the data. It's particularly useful for comparing different categories or groups, making it easy to see how one group measures up against another. A scatter plot. A scatter plot is a type of graph that shows individual data points on a two-dimensional grid, with one variable on x-axis and the other on the y-axis. Each point on the scatter plot represents a pair of values, making it useful for visualizing the relationship between the two variables. This type of graph helps you to see patterns or trends, such as whether the value increases or decreases together. Note: Matplotlib is not included by default in your Python IDE. Therefore, it is necessary to install Matplotlib explicitly on your system. The Matplotlib library comes pre-installed in Google Colab. For other IDEs like Python IDLD, install it using pip install matplotlib. This command uses pip package to install matplotlib from the Python package index, that is pypi. Verifying installation. To confirm installation, run the following command. Note: double underscores are used before and after the version. If Matplotlib is installed successfully, it will display the installed version number. For example, it shows 3.10.0. Understanding Matplotlib. We will create a visual representation of students' math scores using bar charts. Type the following code in the Google Colab notebook. We import the pyplot module from the Matplotlib library using the keyword import, and the keyword as is used to assign a shorter name plt to the imported module from the Matplotlib library. So that instead of writing Matplotlib pyplot every time, you can write plt. We enter data, a list of students and their math scores. We use plt.bar to create a bar chart where the student's name is shown on the x-axis and their scores are shown on the y-axis. To make the chart clearer, we add a title and labels for the axis. Finally, by using plt show, the bar chart is displayed. Now we will run the code and observe the output. A bar chart titled Math Score of Students will appear. The x-axis has been student's name and the y-axis has the scores. The 5 vertical bars represents the math scores corresponding to their respective students. Important functions used in Matplotlib. Plot function creates line plots useful for showing trends over time and continuous data. Let us run the code to see the output. X-axis shows months of the year from January to December, and y-axis shows the average rainfall in millimeter, that is mm. The line plot shows how rainfall gradually increases peaks in the monsoon months, that is June to August, and then decreases towards the winters. Scatter function creates a scatter plot useful for visualizing the relationship between two variables. Let us run the code to see the output. X-axis shows the money spent on advertisements in thousands, whereas Y-axis shows the sales revenue generated in thousands. The scatter plot will show an upward relationship, meaning that as companies spend more money on advertisements, their sales generally increase. Bar function creates a bar chart, often used for comparing categorical data. Let us run the code and see the output. The bar chart shows the sales comparison of different products. X-axis shows the product category, that are laptops, mobiles, tablets, etc. and Y-axis shows the sales in thousands. The bar chart shows the comparison of the sales of each product based on the revenue or money received from the sales of the product. Hist function generates a histogram ideal for displaying the distribution of data. Let us run the code to see the output. The histogram shows the distribution of exam scores of students. It helps to see how many students scored in a certain ranges. Example 30 to 40, 40 to 50, 90 to 100. It helps students spot trends like too many low scores or too many high scores, and can quickly identify if students are passing, failing, or scoring high marks. Pi function produces a pie chart useful for showing proportions of a whole. Let us run the code to see the output. The pie chart shows how the government divides its budget among different sectors. Infrastructure has the biggest slice, while others has the smallest. This makes it easy to see where most of the money is being invested. It also helps understand which areas the government prioritizes for public welfare. Image show function displays an image or a heat map, often used in image processing or for visualizing matrices. Let us run the code to see the output. This code creates a heat map of temperatures across different cities in the state. The matrix values represents temperatures, and image show displays them as colors, where lighter shades, that is blue color, means lower temperature, and darker shades, that is maroon, mean higher temperatures. The x-axis shows the time of the day, like morning, afternoon, evening, and night. And the y-axis shows city A, B, C, D. The output visually compares how temperatures vary across different cities and times of the day. Box plot function creates a box plot, helpful for visualizing the spread and skewness of the data and for spotting outliers. Let us run the code to see the output. The output will show three vertical box plots labeled Maths, Science, and English. Each subject's marks distribution is represented separately. The box shows where most students' marks lie. The middle line inside each box is the median, that is average student performance. The whiskers, that are small horizontal lines above and below the rectangle boxes, shows the highest and the lowest marks within range. Violin plot function. Similar to box plot, but provides more detail by showing the density of the data at different values. Let us run the code to see the output. So we get three lists of marks. One for maths, one for science, one for English. X-axis represents the subjects. Y-axis represents the marks 30 to 100. Each violin shows where the most students scored, that is the fatter area. Spread of scores, top to bottom. Middle performance, median line. Title function adds a title to the plot. Let us run the code to see the output. The output is the straight line graph with the title simple line plot displayed on the top in the center. X label and Y label functions. Label the x-axis and y-axis. Now let us run the code to see the output. X-axis is labeled as time of day in hours. The value 6 am, 8 am, 10 am, 12 pm, etc. are given to the x-axis when someone looks at the graph. They note that the number 6, 9, 12, etc. are the hours of the day. Y-axis is labeled as temperature in degrees Celsius. The values 22, 28, 34, etc. are given to the y-axis, which are clearly understood as temperature values in degrees Celsius. Seaborn. Seaborn is a tool in Python that helps you make visually appealing and easy to understand graphs like bar charts and line charts. It's built on top of Matplotlib, but it makes creating graphs even simpler. Seaborn works really well with data tables, like those you can create using Pandas. And it's great for quickly making nice looking visualizations and understand data even better. Note: Seaborn is not included by default in your Python IDE. Therefore, it is necessary to install Seaborn explicitly on your system. Installing Seaborn. The Seaborn library comes pre-installed in Google Colab. For other IDEs like Python IDLE, install it using pip install Seaborn. This command uses pip package to install Seaborn from Python package index, that is pypi. Verifying installation. To confirm installation, run the following code. Note: double underscores are used before and after the word version. If Seaborn is installed successfully, it will display the installed version number. For example, it shows 0.13.2. Understanding Seaborn. We will visualize both math and science scores for each student with different colors representing each subject. Type the following code in the Google Colab notebook. In the code, we will begin importing the Pandas, Seaborn and Matplotlib libraries as learned before. We create a data frame with students' name and their maths and science scores. Next, we use data frame melt function to reshape the data frame into the format suitable for Seaborn, combining the maths and science columns into one column. This transformation makes it easier to plot both scores on the same graph. We then use SNS bar plot to create a double bar graph with different columns representing maths and science scores as indicated by the parameter HUE subject. We select a color palette, cool warm, to clearly differentiate between the two subjects. Labels are added to the x-axis and y-axis, and the title is included to clarify the chart's purpose. Finally, plot show function displays the double bar graph, where each student is represented by two bars, one for math scores and one for science scores, each in a distinct color for easy comparison. Let us run the code to see the output. We can see a double bar graph of math and science scores of students as the output. In conclusion, we explored the world of data analysis using Python. We started with Pandas, a powerful tool for handling and manipulating data in tabular form, which helps us clean and organize data efficiently. We then looked at NumPy, which provides support and numerical operations and is essential for performing complex calculations quickly. Next, we examined Matplotlib, a library that allows you to create various types of graphs and charts to visualize our data, making it easier to understand patterns and trends. Finally, we dwelled into Seaborn, which builds on Matplotlib and provides a higher level interface for creating more visually appealing and informative statistical graphs with simpler syntax. Together, these libraries equip us with tools needed to turn raw information into valuable insights and help us make more informed decisions. That's all for today, students. Hope you had fun learning more about Python analyzing data. Want to test your brain? You can attend a quiz of this chapter on Dattam's website. Once you finish attending the quiz of all the chapters, you will receive a certificate. Scan the first QR code to visit Dattam's website or click on the link provided in the description box. Scan the second QR code to learn how to navigate to assessment page and access the quiz section on the website. or click on the link provided in the description box. You can also download this PPT from the Thumbs website. Great job, little genius! You have finished lesson 3. Don't forget to like, share and subscribe. See you in the next lesson. Happy learning!